Hi folks, this is just a video I've made on an ignition coil driver. Now this is a very simple setup. Now I'm just starting out with electronics, so I'm not too clued up on how to do advanced circuitry or anything like that, which is why I haven't gone for the more popular and efficient method of using a 555 timer to drive this ignition coil. Now, there's tons of videos already on the internet with using a car relay to drive these ignition coils, but from what I could see, there wasn't really any sort of great detail on how you wire it up. I know that some people talk about, yeah, you do such and such with normally closed contacts and things like that, but my relay doesn't have that information on it. What my relay actually has is numbered terminals. Okay, and this diagram here basically shows you how I have wired up the setup here. Okay, now my car relay comes with terminals numbered 86, 87, 85, 30 and 87A. In this setup here, 87 isn't used. Okay, I've also incorporated a 220 nanofarad capacitor or 22 microfarad capacitor at 500 volts rating. The battery that I'm using to power this setup is a 12 volt battery with 7 ampere capacity. There it is there, and it's just a standard 12 volt ignition coil. There's your high voltage output. I've just got an Allen key there and just a metal rod there with a gap there, which basically is my spark gap. Okay, now back to how I've wired it up. Okay, so start with terminal 30. This is one of the contact terminals. I've got a wire coming from terminal 30 going to the negative side of the battery, another wire from terminal 30 going to one leg of my capacitor. The other leg of my capacitor goes to terminal 87A. Okay, 87A also has a wire going to terminal 85, which basically turns the relay into a buzzer whereby the contacts open and close lots of times a second, basically, because these transformers, which is basically what that ignition coil is, won't work from just continuous power going through it. It has to receive a pulse of DC, and basically this is basically shorts out the relay, and then it basically switches off, then it goes back again and switches, and each time it makes a connection it sends a pulse of power to your ignition coil here. Okay, so that's basically what's happened there, right? So with terminal 86 we've got a wire coming to the positive terminal of the battery. There's also a branch of wire connected to the same place, basically going to the positive terminal of the ignition coil. The negative terminal of the ignition coil goes to 87A as well. Okay, now I'll just sort of hover over this for a few seconds just to let you see how that is wired up. Now, like I say, I've seen plenty of videos with this setup, but none which basically, well, to my mind, sort of tell you how you properly wire it up. Now, if you buy a relay, car relay, mine's 40 amp relay, 12 volts, 40 amps. Try and go for as high an amperage as possible, which means your contacts in the relay might last longer. Okay, just a word about the capacitor. The capacitor actually seems to increase the intensity of the spark. I don't know why that is. If somebody wants to leave me a comment and tell me why that is, that's absolutely fine by me. Any comments on how I can improve this setup to get longer sparks, also feel free to leave me a comment there. Just one thing I will say is try and use a decent wire here, with a decent thickness of insulation, and try and not have your wires sort of touching the body of the coil. And if you choose to run a wire from the high voltage terminal instead of the Allen key, which I've done here, then make sure that that has got a fairly good thickness of insulation on it, because I have had a scenario where basically I've ran this and there's been a thin wire coming out of here, and basically you can put it a few millimeters from one of these terminals here, the negative, and it'll create a spark, but obviously if the wire is too close to anywhere in that body of the coil, it will spark through the coil. Okay, and if the insulation is not thick enough, you can actually get a shock off it as well. Now, I wouldn't recommend that you run this off the mains. I originally did try and run this from a 12 volt adapter, which basically is a wee adapter which puts out 12 volts at 1.5 amps, and that was fine. That's not going to kill you, okay? But what I actually found is when I tried to switch the power off to the adapter, I actually got a slight tingling from the plug socket. I don't know what that is. I wonder if maybe the coil gave a feedback voltage to the adapter I was using. Then again, if there's any electricians out there, you might be able to tell me why that happened. But so I've resorted to running it from a 12 volt battery because I don't want to use the mains. I don't want to get a shock here. Anyway, enough of my rambling on. Let's get this connected and see some sparks. Now, as you can see, those are fairly aggressive sparks there. Without the capacitor, this will still work, but the sparks won't be as aggressive. I believe the function of the capacitor is actually to preserve the contact terminals in the relay from being basically eroded fairly quickly, but I'm not really too sure, because when you put the capacitor into the setup, obviously it does boost the intensity of the spark there. So if anybody can tell me why that is. And the other thing is, if you leave this running for any length of time, it does generate a smell which is not very pleasant. If anybody can tell me what that might be, I'd be grateful also. So there we have it. That's my simple high voltage setup. I'll just give you a close-up of the relay there, and basically what I've done with the wiring there. I hope you found that interesting. Like I say, any comments, go ahead.